Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. In this video, I will discuss the solution for topic 5, circular motion. But I continue with the question number 7 to 11 so that you can prepare yourself for the ujian selaras next week. For question number 7, a particle moves in a horizontal circle of radius 15 cm inside the inverted smooth hollow hemisphere, as shown in the figure 5.5. First, you need to sketch a free body diagram showing the forces acting on the object. And question B, you need to calculate the speed of the particle. Firstly, to sketch a free body diagram, you need to identify the surface in contact between the object. Okay, so I just do a straight line, the red straight line represent the surface in contact between the particle with the hollow hemisphere. And then our object, a particle as a point object, the forces exerted is the weight of the object and normal force which is perpendicular to the surface. So referring to the motion of the particle, we can identify that the motion of the particle is a horizontal circular motion. Because of that, the centripetal acceleration is directed to the center of the circular path. So this is your answer for the free body diagram. Alright. For B, to calculate the speed of the particle, can you do the separate free body diagram so that you not disturb your answer in A? My suggestion. But I will do on the same diagram. Okay. So referring to the free body diagram, N is not because of AC is horizontal circular path, circular motion at the horizontal circular path. So we need to resolve the N to the NX and NY. Because of N is not at the X or Y component. And then there is a theta there because of it is involved the resolving vector, so you need to know the theta. So this is the hidden info where you can get the theta by calculating using the cos theta. Okay, and you get that theta is equal to 60 degree. And first, because we want to calculate the speed of the particle, take a look at the x component. The concept that relate at the x component for the horizontal circular path is total forces exerted is equal to centripetal force. Do take note that centripetal force is net force. And if you refer to the diagram, the forces at the x component is only nx. So you will get the equation of n cos theta is equal to mv square over r. This is our first equation because of you cannot get the v directly from this equation. You need to know the value for mass and normal force is not given. Now we will take a look at the second component, which is y component. At the y component, total forces is equal to 0 because of the object is not moving in the circular and vertical path. And because of it is equal to 0, we follow the sign convention. Upward force positive, downward is negative. We get the ny minus w is equal to 0. And our ny is equal to n sin theta and w is equal to mg. We get the second equation. From the first and second equation, to solve it, we will divide equation 2 to equation 1. We get the tangent theta is equal to rg over v square, and you substitute all the value that you given from the question and also the hidden info. You will get the v, which is equal to 0.92 meter per second. Okay. For question number 8, figure shows a ball connected to a massless string to a vertical and rotating rod. So the string are tied and the tension in the upper string is 35 Newton. First, you need to sketch the free body diagram of the ball. To sketch the free body diagram of the ball, you need to identify the point object and also the types or the case of the circular motion. So in this case, because of the ball rotating with the rod, so the ball make horizontal circular motion. And then if you look at here, there are, of course, referring to the free body diagram, there are a weight of the object of the ball, and then tension in the upper string and tension in the lower spring, represented by T1, T2 respectively. So this is a free body diagram referring to the diagram figure given. For question number B, you need to determine the tension in the lower string. So first, to calculate the tension in the lower string, we can get few hidden information because of we need to resolve the tension after this. So first, the hidden info is the theta. You can calculate the theta using the sin theta. So you will get theta is 30 degree, and also at the same time you can calculate the radius of the circular path of the ball. And then this is considered our hidden information. Now we want to calculate the tension. To calculate the tension, first you need to identify the centripetal acceleration of the motion, and centripetal acceleration is always towards the center of the circular path. To calculate the T2, to make it easier calculation, we can refer to the Y component first. Okay, after we resolve the T1 and T2. So at the Y component, total forces exerted is equal to 0. And then we follow the sign convention. Upward force is positive and downward force is negative. We get the equation of T1Y minus T2Y minus W is equal to 0. And when you substitute all the related value, you will get that the T2 is equal to 8.71 Newton. To determine the net force on the ball, do take note that the net force is represent the centripetal force. Because of that, centripetal force of course relate to the AC, right? So AC is at the X component. We can refer to the forces exerted at the X component, where our concept is total forces exerted is equal to centripetal force. Okay, because of that, we want to calculate the net force, which is centripetal force. So there are two forces only at the X component, which is T1X and T2X, and both same direction with the AC. So both is positive, T1X plus T2X, and you substitute the value, you will get the centripetal force, or the net force on the ball is equal to 37.85 Newton. Okay, the third one is you need to determine the speed of the ball. For the speed of the ball, because we have the value for the centripetal force, we can use Fc is equal to mv square over r, and you can substitute the Fc that you have calculated into, and then the mass is 1.34, and also the radius that we have calculated the hidden info 1.47. You will get that the speed of the ball is equal to 6.44 meter per second. Okay, for question number 9, it is quite simple because of the object is moving with a constant speed in the vertical circle. So the red color is represent the object with the mass m, and the string length is L, which is also represent the radius of the circular path. First, you need to sketch a diagram illustrating the forces acting on the object when it is at the top and at the bottom of the circle. So referring to the solution A, you can sketch first at the bottom. So at the bottom, the tension always, for the tension, it is always away from the object. So the tension is directed upward or to the center of the circular path, and the weight is downward. For the at the bottom, at the top, because of the tension is always away from the object and the tension in the string. So at the top, the tension is directed towards the center of the circular path, or also downward. Okay, and the weight is also downward. So this is the free body diagram showing the forces acting on the object at the bottom and at the top. For the B, write expression for the centripetal force acting on the object in terms of mv and L. So in this case, as I mentioned earlier, L, the length of the string, is represent the radius of the circular path. Because of that, the centripetal force is equal to mv square over r, and our r is represented by L. So you get the expression for the centripetal force in terms of mv and L. For question number 9C, if the string breaks, at which position will be likely to occur? So you can answer either at the top or at the bottom. How you want to identify the correct answer? You need to do a short analysis at the top and at the bottom. So take a look at the top. If we do the analysis, we refer to the forces exerted on the object at the top, which is T and W in the same direction. And the net force is equal to the centripetal force. So we get the equation of T plus W is equal to Fc, and T is equal to Fc minus W. Okay, we compare with at the bottom. If you look at the bottom, T and W is in the opposite direction. So we get the equation of T minus W is equal to Fc. And T is equal to Fc plus W. From these two analysis or two equation, we can say that the tension is greater at the bottom compared to at the top. So your answer can say that, tension at the bottom is greater compared to at the top, so the position which likely to occur for the swing brakes is at the bottom. For question number D, given the mass, the length and the V as shown, as given. So you need to calculate the maximum tension. Just now we know that comparing to at the bottom and at the top, the bottom is higher, or we can say the maximum tension is at the bottom. So we can use that equation, okay, T at the bottom. And then we substitute the value for net force and also the weight. When you substitute, you can calculate, you will get that the maximum tension is 8.82 Newton. For question number 10, it is about the Ferris wheel. So Ferris wheel is one of the vertical circular motion. Okay, the example of vertical circular motion. So this Ferris wheel, the diameter is centimeter and rotated at the rate of 4 rotation per minute. Okay, referring to the question, we have the hidden information, which is omega is 4 rotation per minute, or if you need to change to the SI unit. So referring to the SI unit, 4 rotation per minute is equal to 0.42 radian per second. The first question, you need to calculate the acceleration of the rider on the wheel. So the acceleration of the rider is represent the centripetal acceleration. So it is equal to r omega square. We can use r omega square because we have the value for r from the diameter and we have the value for omega. You substitute the value for r and omega, you will get the acceleration of the rider is equal to 1.59 meter per second minus 2. So for question number B, you need to calculate the magnitude and direction of the force which the seat exerted on a 40 kg rider at the lowest point and the highest point. So to calculate the normal force which the seat exerted on the rider is represent the normal force. So to calculate the normal force at the lowest point, we need to refer to the free body diagram at the lowest point. So referring to the free body diagram at the lowest point, N is directed upward or to the center of the circular path and W is downward. Referring to the free body diagram, we get the equation of N minus mg because of N same direction with AC. So it is equal to FC. N minus mg is equal to FC. And if you calculate N, when you substitute, you calculate the N, you will get the N at the lowest point is equal to 456 Newton. And don't forget to mention the direction, which is upward, or as shown in the free body diagram. At the highest point, same thing. We want to calculate the force which the seat exerted on the rider, represent the normal force. We refer to the free body diagram at the top or at the highest point. So we get that N upward, W is downward. But in this case, because of W is same direction with the AC, so our equation is mg minus N is equal to FC. And you substitute the value, you can calculate the normal force or the force at which the seat exerted on the rider is equal to 3 to 9 Newton. And the direction is upward. Okay, same direction with the first. Okay, for question number 11, it is a vertical circular motion. The second example, the second case of the vertical circular motion, which is about the roller coaster car. So this roller coaster has a mass of 1,200 kg when fully loaded with the passengers. As the car passes over the top of a circular track of radius 18, which is the position is upside down position, its speed is not changing. What are the magnitude and direction of the force of the track on the car at the top of the hill if the car speed is 14 meter per second? So the force on the track on the car at the top is represent the normal force because of the track exerted on the car. Our object now is the car. Alright. So how to calculate? As usual, when you want to form the equation, you need to sketch the correct free body diagram. For example, at the top, the direction of free body diagram is normal force downward because of the car now is upside down. Okay, same direction with the weight, which is toward the center of the circular path of the roller coaster. Okay, referring to the free body diagram, we can write down that the N plus mg, because both same direction, is equal to Fc, same direction with the AC actually. Okay, and then you can rearrange the equation, you substitute the value, you will get that the normal force, okay, is equal to 1.295 kilonewton. And don't forget to mention the direction because of you need to state the direction to direction is downward. So that's it for the solution for the tutorial question topic 5 circular motion set question number 7 to question number 11. I hope that it can help you to do the revision and you can understand the application of the centripetal force especially in the circular motion. All the best for UPS 1.